Okay, welcome back to the C programming lecture series. Today we will try to see problem solving strategies. If you see here, so suppose we have a complex problems or complex task if you have. So this complex task is not able to easily solve. So to solve this complex problem or complex task, we will need to follow some strategies. Okay. So, what is the one strategy? So, whatever complex problem is there, that should be divided into, okay, that should be divided into smaller manageable parts. So, we have a large complex problem that should be divided into manageable parts. Okay, then so each part will have a added efficiency such that we will be getting a higher efficiency for our complex problem. So here we have a large problem. The large problem should be divided into sub problems or programs. So those we called as a modularity, such that those problems are solved individually there itself and they are added together and will be getting a complex problem solution. So that is nothing but one problem solving strategies. So there are two types of problem solving strategies are there. First one is top down approach. Second one we have a bottom up approach. Okay. So these are helpful when you are designing algorithm programs and systems for a complex tasks. Okay. Now we will see one by one. First one we will try to see top down approach. Top down approach is nothing but if I see, suppose we have a large complex problem. Okay, we have a large complex problem. Here we will have a input and we will know the output of this complex problem. Okay, so we'll be giving input to this complex problem and we'll be giving output to the complex problem. Here, what we try to do. So whatever complex problem is there. Sorry. Okay, you see, we have a complex problem where we have a input and output. So this complex problem was divided into some convenient small programs or problems. These small programs or problem solved somewhere else. So whatever small problem is there that will be solved at here individually. So this is another small problem and this is another small problem. So whatever large complex problem is there that was divided and see this main program was given a individual task to the subprogram such that these subprograms will be finished here itself and they will be giving or returning output to the complex problem or main problem. Okay, so this is called top down approach. The subprograms or subproblems, they don't know what they are doing, just they are taking input and returning the result to the main problem. Okay, so suppose this is our main program. This main program is calling some subprograms. Okay, this subprogram giving result. That result will be uh, carried to main function or main program such that the problem was solved by the main program only. So the total credit was taken by the main program. Okay, so that is about a top-down approach. But in bottom-up approach, we have a individual subprograms are there. So there are independent subprograms will be there. So they are doing they taking input and they will be giving some output. Okay, so there are some input and there are outputs are there. So what will happen here? So later we'll be writing a complex problem. We have a complex problem where we are writing a program or code. So it required some data. So that means it required some output such that what it is, the code it is already available in subprogram. So it will call that subprogram and the it will will be generated by the subprogram. Similarly, it will call another subprogram and another subprogram. So the all these subprograms are giving output that will be stored in the main program. Here we'll be getting final output. Here, what is happening? So in bottom-up approach, the subprograms they are working individually. So they are not written by the main program. They already written and these are helping your main program later. But in top-down approach, we first intended to start the main program. So whatever required tasks are there, those are divided into subprograms that will be written somewhere else, and those will be called at here such that we'll be solving a big picture here. Okay, but subprogram, so already written programs are there. Those we are taking help when you are having a complex problem. So this is called bottom up approach. This is called top down approach. Okay, then we see now. So that is called top down approach and bottom up approach. Okay, then you see bottom up approach is nothing but starts with a small under the basic component and it builds the main solution. So that is the difference between top down approach and bottom up approach. Now in top down approach, we seen, so it is nothing but it is a decomposition method. So we have a main program that was decomposed into subprograms. So begins with a larger program at a higher level. Okay, the main goal is first defined in the main program. So it is then calling the subprogram such that the task goal will be finished. So whatever goal it is known by the main program only. So that goal or task is done with the help of subprograms or modules. Okay, so this is like outlining a book's chapter because every if you open a book, there are outline chapters are there, book chapters are there. So that is called main function or main program. So when you go to individual chapter, there we have a content. So that means those individual contents or individual chapters are the subprograms. Okay, so that is about your top-down approach. Then if we see that. So there are steps are there for obtaining your top-down approach. If you see, so first we need to identify the main problem. Okay, we will be defining in the high level. Then we'll be decomposing into subprograms. Then later we will be refining if there are issues are there. Okay, with if the subprogram itself it will become larger, then if the subprogram itself it will become larger, then what we'll try to do, we will try to divide that subprogram into some other subprograms. Okay, so then we'll be implementing the bottom, that is subprograms. Then the subprograms are integrated. Okay, so they will be tested there and it will be carried to the main program. So whatever errors it will be handled in the subprogram. Okay, so these are the steps involved in the top-down approach. Next, we have advantages of the top-down approach. First one, if we see, okay, if we see, it is easy to understand because big picture we already known, the main program we already known what we are taking and what we are giving output. So when you are writing main program itself, we will understand if there are any defects are there. Okay, we'll be starting with the main program. So what are the inputs we need to take? What is the output we need to give? So those things we already known in a starting of our main program. So before writing our subprogram, okay, if there are any defects or drawbacks are there, there itself we will rectify. So it is modular code. That means subprogram coding is called modular coding. So it is good for team collaboration. Okay, so we have a 10 members of team. Suppose we have a project will be there. That project will be divided into individual members. So that is called top-down approach. Then coming to disadvantages, if your main program is not managed properly, that means whatever task we intended to give, if they are not given properly, then there is a drawback. Okay, so what we are saying, what we are sharing to subprograms, we already known. After that integration, if we are integrating those subprograms, it intended to give final output. If it is not giving, that means it is not fitting exactly to our intention, then it is a drawback. So the overall approach is a wrong. Okay, requires good initial plan. I already said. So when you are writing a main program, there itself you should clearly define what are the subtasks will be having, how those should be integrated, if there are any issues in defining that subprogram, or are there any issues while distributing the subprogram. Initially, we will plan that one. Okay, so that is the top-down approach, advantage and disadvantage. Now, we see a example. So we have an example. Check if a number is a positive, negative, or zero. So for that reason, what you are doing, we'll be following top-down approach. In high level, what you are doing, our aim is to read a number and print whether it is a positive, negative, or zero. So our priority, our main program is nothing but we'll be taking some input and we'll be saying whether it is positive, negative, or zero. So for that reason, we'll be decomposing. That means we are dividing our main program into two tasks. First one, reading a number. Okay, so we will read a number in some other subprogram, and will decide whatever read number, whether it is positive, negative, or zero in some other program. Okay, so if I want more refined, then what I will do, I will divide again my first subprogram into another function. Okay, and the second subprogram also another function. For positive, negative, we'll be writing some other function. Okay, so this is the example for a top-down approach. Next, if you see, I already said in starting. So first we'll be defining main program. So this is the main function we'll be defining first. So here our intention is to read a number, and our intention is to tell whether number is a positive, negative, or zero. So the main function gives our outline. We will be taking some input and we'll be saying whether it is positive, negative, or zero. That is our intention. So, but reading a number, deciding a positive, negative, or zero was not done in the main program. So that was done in the subprogram. You can see at the bottom, we have a function or subprogram which is a read a number. Here it reads the number. Okay, just it we in main program we are calling this subprogram read a number. So it will come here and it reads the number. We'll be entering a input here. It is asking enter a number. We'll be entering a number that will be transferred back to here. Okay, then it is again calling a function which is tell if a positive, negative, or zero. So there we have another program. We have written it here. This program, subprogram tells if the whatever entered value is greater than zero, it is a positive. If it is less than zero, it is negative. If these two are fail, then it is a zero. Okay. So this is a subprogram. where it tells whether it is positive, negative, or zero, whatever entered value. Then this is transferring to your main program or main function. Here we'll be getting output. So here, so we'll have a input function and output function. In main program itself, it is saying that in detail we'll be taking some number and will giving whether it is a positive, negative, or zero. But the task was not by the main program; it was done by the some sub program. So this is called top-down approach. Next one we have bottom-up approach. In bottom-up approach, I already said. So first we'll be writing some basic components or modules or subprograms. These will be tested there individually and they combined and forms a larger program. So that is called bottom-up approach. It is like building a house by brick. Okay, so that is called bottom-up approach. Then if we see, there are steps in performing bottom-up approach. First one, so first we'll identify basic components. So we'll be defining, we'll be writing subprograms first. Then we will be implementing and testing these subprograms individually. Then later we will be integrating this subprogram into large function or large program. Then uh, we will be integrating or will be doing some refinement in the main program such that these subprograms integrate in efficient way. Then we will test the main program. So after integration, we will have a complex problem. So that complex problem we will be testing. And if needed, we will be refining that subprograms and we will be refining our main program. Okay, so that is called our bottom up approach. Then if I see there are advantages and disadvantages of bottom up approach. If I see, so if there are any early detection, early issues are there in subprograms, we can rectify there itself. Okay, before integration, the subprograms we can refine in the subprograms itself. So once we written a subprogram or module, those can be repeatedly used for any other complex problem. Okay, if in future if we are writing any program or problem, so there if these modules are needed, then we can use these modules there. So we can have reusability of programs. So that means these will be utilized as a existing library. So such that we can use these modules in a future programs. Okay, so this is a that means parallel development is very easy. So one if you have a team of 10 members, we can give one sub program to one member, another sub program to another member. That means we can distribute these sub programs to individual. There they are performing their task and they are completing, and that sub programs will be combined and will be getting a final output. That means it is a time saving. Okay, then uh, if uh, because we don't know what is the output main, we don't know what is the main function. So for that reason, we written individual programs. If these individual programs intention is not met our main program, then it is a drawback. Okay, if this integration is uh, if when you are integrating, if it is not fit properly in the main program, so then it is very difficult to merge these sub programs. Okay, so that means it is very challenging to add these sub programs into main program. Okay, so this is about your bottom up approach. Then I already said in bottom up approach, uh, now you see we have an example here. Our aim is to, now you see, our aim here, we don't know what is our aim. But if we see, we will be written a subprogram. The subprogram says adding two numbers. will be taking input A, B, and will be adding A plus B. So this is a subprogram which gives output is addition. Similarly, we will have another subprogram which will multiplies A and B. It will be taking A and B and it just multiplies and gives the output is a multiplication. Okay, so this is another subprogram. We don't know what we try to do in future. We don't know, but we return these subprograms early. After that, after writing this subprogram, so we'll be have another subprogram here. Just will be printing the addition and multiplication values. Okay, in previous subprograms we are not printing anything, just we are storing the result. Those result will be printing in the another subprogram. So our intention is not yet known. Then later we have a main program. Here we will be taking inputs. So we'll be taking first number and the second number will be, if I need a summation, I will be calling add function. I will be adding number one, number two. And if I need multiplication, I will be calling multiply function subprogram. Then I will be transferring whatever entered number one, number two, that one, and I will be obtaining multiplication. Finally, I will be printing summation and multiplication values in the main program. So try to understand here. Uh, we don't know intention. Okay, we don't know intention. So first we will return subprograms for addition and multiplication and printing. Later we'll be using this subprogram for our convenient. Okay. So this is called bottom up approach. Okay. Then okay, this is how we will finish today's lecture series. So our today's agenda is problem solving strategies. There we seen top down and bottom up approach in detail. Okay. Thank you.